Okay, so let us start with the today's class. So I am a PMRF scholar. My name is Sugan Pargal, and I'm here to discuss with you. Just, so I'll be taking your NPTEL Computer Networks and Internet Protocol live sessions. In this live sessions, let us just wait for 5 minutes so that all of you get admitted once, and then I'll just describe what will be the outline of these live sessions, how these live sessions will be conducted. And I request everyone to please mute your mics. So my name is Sugan Pargal, and I am here for you for the live sessions of the course Computer Networks and Internet Protocols. In this live session, what we'll broadly cover is whatever you have been taught in the NPTEL coursework in the entire week, and then we will discuss about the basic outline of whatever topics are being covered. And after that, we will cover a few questions and their solutions, which will be uh, your baseline for solving the assignments that will be coming in the upcoming week. Okay, so we will primarily discuss a few terminologies and the concepts that have been discussed in the lectures, and thereby we will discuss the questions and their solutions related to it. And in this session, we'll also discuss about the previous assignment, whatever assignment have been allotted to you in the previous prior week, and their solutions when they are out and been given. So we will discuss, and if any one of you have any queries regarding those questions, you can also put up here, and I'll explain those as well. Okay. Let me take all the students in at one go, and then we'll start in 5 to 10 minutes. So I hope everyone is able to see the screen which I have shared with you. So firstly, in this first week of NPTEL course, we'll discuss about the introduction, basic terminologies and the basic outline of what exactly is computer networks and what are the internet protocols that are used in for the computer networks course. Okay. So how does computer interact? So there are two computers which interact with each other with the help of a network protocol stack. So one machine is interacting with another machine. So there is no physical link to both of them. It's just that there are certain rules which are called the protocols with the help of which two computers interact with each other. So these are the typical components which are used in local area network. Firstly, there are clients. These are the workstations on which people work, and then there are server, which usually have more computing powers. So the client requests the server to perform different operations and perform different jobs so that the servers can perform them and then give the output to the client. So because clients are the workstations which have less computational power and they are not having the capacity to conduct each and every operation. So for heavier operation or more operations or jobs with more computational resources, they are sent to the servers. So for the interconnectivity between different clients and different servers and among clients and servers, there are different network devices used. These are known as repeaters, hubs, bridges, switches, and routers. Okay. So now that we have discussed how does it two machines interact with each other, so we see that there is a set of protocols with the help of which the machines are able to interact with each other. Okay. So these protocol is a controlled sequence of messages that is exchanged between two or more systems to accomplish a given task. For example, if one machine asks the other system to, for example, from one machine we have to send an email to the other machine. So for that purpose also we need a set of protocols. We need a protocol which decides how the that one email is transferred from one machine to another set of machines. Okay, so these kind of rules which are defined for the exchange of operations and the exchange of messages between two systems is known as protocols. So protocol specification define the sequence together with the format and layout of the messages that are exchanged. Yes, just a minute. I'll just okay. So there are different types of layered architecture which defines the protocols which needs to be decided for the interaction between two machines. So the first type of model is the OSI models, which has 7 different layers for the network protocol. So the first layer is the physical layer. We start from bottom to up. The approach which we follow is bottom to up to admit everyone. Okay. Yes. So, first layer, I was talking about the OSI model layers. So, we will start from bottom to up approach, and the first layer is the physical layer, which helps in transmission of binary data of a medium. Like, for example, we have two systems, and the transfer of data from one system to the another is done with via a physical layer, that is through a physical medium. Then comes the data link layer above the physical layer, which helps in transferring of units of information. For example, framing and error checking. So in this layer, when we have the physical connection, but there are certain moments when we are not able to transfer all the information using that physical connection. So for that purpose, we need the data link layer, which helps in framing each each information and then provides the error checking as well. I can show here with the example, like there are two computers and they are connected via the means of physical layer, in which they are communicating with each other, and the physical layer helps to convert the digital data to analog signal and vice versa. Next, let us talk about each layer one by one, and then what are the technologies, or what are the network devices which are being used in each layer. So firstly, we are talking about the physical layer, and that requires a physical connection in which the data is transferred from one computer to another. So the devices which are used are NIC cards, repeaters, and hubs. So to connect to in computers, you must install a NIC card in each of them. So that will attach the computers using a crossover cable. So the NIC card is required to connect the two computers. However, that is not a very durable approach, because for that purpose you need to place the computers very close to each other. So to avoid that barrier, the repeaters are used when the computers are placed at a distant location to each other. They helps to increase the distance and let the computers interact with each other. So the range in which the for which the repeaters are used. So as we talk about the physical layer, so the connection between them is physical, but that the connection is I mean we say that it is physical, but the connection is not made with the help of wires. So the connection is wireless only. So the repeaters are used to just like for example you have the Bluetooth. So the systems are connected using the Bluetooth with their range antennas. So the repeaters are used to increase the distance between the two devices. So the range of them is 100 meters to approx 300 feet. So next purpose is like for example, if you want to connect multiple machines, for that purpose you need a hub, because a repeater can is only able to connect one machine to the other machine. But if there are multiple machines in the same uh, network and they want to interconnect to each other, then the repeater will not serve the purpose. For that purpose, we need a hub, which is again a multi-port repeater, which has multiple repeaters in, which have multiple port for repeaters in it, and it is able to connect to different machines at one go. So in hub, if host one wants to ping to host two, all the host sees the ping, so that it does the broadcasting of the messages. So if a request is made by one system, the hub will communicate to all the systems which are present in the network or to which that hub is interconnected. So the hub, that is what it means by broadcast technology topology. So the hub follows a broadcast topology. So the disadvantage of this broadcast topology is that it might leads to collision at major instances when there are multiple requests at one go. So for that, what we need is a smarter hub, which is called a bridge. So that bridge is used in the data link layer, as we mentioned, because it filters out the network traffic based on the MAC address. What is the MAC address of that system? Based on the MAC address, it filters out the network traffic and allows a system to communicate with the other system based on the MAC address. Okay. So we move back again to data link layer, which helps in transfer of units of information, and it fragments the unit of information into different frames, and then does an error check whether the data is whether the data is correct or not, or the received data is correct or not. So that functionality is done by the data link layer. So in data link layer, as we have seen, we use the bridge. Yes. So in bridge, what it does, it is a multiple, it is a kind of multiple hub kind of thing, in which it lessens the amount of LAN traffic, and the communication is filtered based on the MAC addresses only, as we talked about it. So now if the host one pings to host two, only the host on the LAN segment sees the ping. So the bridge stops the ping to get transferred to all the other machines or systems on that particular network. So as you can see here in the figure, from 1 to 2 only it is able to communicate. So till now, anyone has any queries? Okay. So now if we need a multiple bridge, like we need to communicate between host 1 to host 2 and host 1 to host 3 and host 1 to host 5, but they are all on different LANs and different networks. So for that purpose, we require a multi-port bridge, as we require a multi-port repeater as a hub. Similar in case of multiple MAC address filtering, we require a switch as a multi-port bridge, which can effectively replace these four bridges and can be used directly. Like these are the four bridges that you can see, 1, 2, 3, 4. So it replaces all the four bridges, and we only can use this switch for the easily connectivity of these machines. So another benefit of the switch is that each LAN segment gets dedicated bandwidth, that is the similar bandwidth of, for example, say 10 Mbps. So, but in case of hubs, we are not able to get a dedicated bandwidth because a single request, a multiple request, a broadcast messages are spreaded through hub, and the bandwidth gets distributed. So now comes a bigger network. So there are multiple. Anyone has any query, like, or can you mute your mics if you do not have? Lakshya bed.
Ma'am, what about the repeaters?
Yes, so I told you repeaters are basically for increasing the distance. For example, say the two machines are separated far away, like more than 100 meters. So then comes the usage of a repeater. For example, if we have two machines placed next to each other, then an NIC card would also work. So then
Okay,
one machine will
ma'am.
be able to interact with the other machine. But if the two machines are far away from each other, that is more than 100 meters, then the repeaters are used to extend the distance.
Ma'am, it also like it makes the connection strong also, no, ma'am. The network, it makes the network strong from weak signal to strong signal
Yes,
by
yes, I mentioned that point as well. Like one benefit is that it increases the distance, and second benefit is that it enhances the network stability and the bandwidth as well.
ma'am. And what about the switches? Does it stores the MAC addresses?
The switches, yes, the switches are able to store the MAC addresses. I mean, whenever a request is made in case of switch, it is able to filter it based on the MAC address. So as you see here, in case of bridge as well, bridges and switches are one and the same thing, but the difference is that individual, if you want to connect, you have to place different bridges, but a switch is a network layer is useful. And it also converts these, it also fragments these packets into different fragments, because there might be a case that if you send a packet from one machine, but the size of the packet of that machine is very huge, but the machine which is able to receive that packet receives a less volume of packets. So for that purpose, you need to fragment the packet into chunks and then send the packets. So all these functionalities are done using the network layer itself. Okay, so for the purpose of routing in network layer, we use routers. They find out a suitable path to forward the data from one network to another network. So the routers filter traffic based on the IP address. So previously we see that the switches and bridges filter out the traffic based on the MAC address. And now the routers filter the traffic based on the IP address. The IP address tells the router which LAN segment the ping belongs to, and then it sends to particular LAN segment. As you can see here, if from one host, the host 1, we want to send ping to host 16, but they belong to a different network. So for that purpose, we need a router between them. Then comes the transport layer, which is used for end-to-end communication. So now it provides end-to-end reliable communication. It is able to transfer the message, it is able to make the systems communicate with each other from for one process to another process. Then comes the session layer, which helps in establishment and maintenance of the sessions. Then there is a presentation layer which helps in data formatting and encryption of the information transferred. And finally, it's the application layer, which helps the network's applications such as file transfer and terminal emulation and other applications as well to function properly. So we started from bottom to up. But when we are facing it in a real world, then we see the process occurs in top to bottom fashion. Like we start with the application layer, then the application sends from one machine, the application sends a particular message. For example, the email application, it wants to send one email to another application in another system. Then the application layer comes into picture, then the presentation layer, how the data is formatted and encrypted, that email data. Then the session layer, it establishes and maintains the sessions for a particular duration between the two systems. Then the transport layer, which makes an end-to-end reliable connection and helps in the delivery of the packets. And then comes the network layer, which find out a particular IP in which to which that email needs to be transferred, and help how it will be routed from one network to another. Then comes the data link layer, which helps to transfer the unit of information and does the error checking at the receiver's end, whether the received messages are correct or not. And finally, it's the physical layer, which converts the received messages of binary data from the digital to analog and analog to digital signals, respectively, based on the sender and the receiver. Uh, can you just mute your mics? Okay. These are the 7 layers. So I hope everyone is clear with these 7 layers. Now, this was the OSI model that we have seen, but that is just a theoretical model that we understand in theory. But in real world and the practical implementation, we use the transmission control protocol, that is the internet protocol, or TCP/IP model. The TCP/IP model is a suite of protocols that has become the dominant standard for internet working. So the TCP/IP represents a set of public standards that specify how packets of information are exchanged between different computers over one or more networks. So as you have seen this, in OSI, we have categorized different layers and what are their functionalities. But in real world, the top 3 layers, that is the application, presentation, and session layers, the operations and the functionalities they perform has been combined together as the operations and functionalities of one layer, that is the application, as well as the transport layer. Some of the operations are being performed by the transport layer and some of them are performed by the application layer. Apart from that, the network, data link, and the physical layer are the similar in case of all. Uh, does anyone mention in the chat not able to see the PPT? All of you, can you see my screen?
No, ma'am, the PPT is not visible.
So for how long are you not able to see the screen?
It's
Now,
been no, it's been 5 minutes.
for how long you have not been able to see the screen?
Around 5 minutes.
Okay, then it's fine. Okay, okay. Now is it visible, right?
Yes, yes.
Okay. So the OSI and TCP is the difference. The difference between them is only that the OSI is the theoretical representation and the TCP/IP is the practical representation. How exactly the system works, or the networks, or the two computers are interconnected and how they interact with each other. So there are multiple applications there are multiple protocols which are useful for which are being run on different layers of TCP/IP protocols. And the application protocol has HTTP, FTP, SMTP, and then the transport layer supports TCP, UDP, and RTP. And network layer supports IPv4, IPv6, MPLS, and data link layer supports Ethernet, Wi-Fi, Bluetooth, UMTS, LTE. And then there is a physical layer, which is a physical connection. So these are the protocols which we will be discussing later in the coming weeks. It's just an overview of what are the different protocols being used by different layers, because each layer has a predefined set of rules, and with what types of rules you want to communicate depends on the type of protocol. And there are then different protocols which are placed in the in between the two layers. For example, DNS, which works some part in the transport layer and some part as an application layer, and SNMP, which again works as a transport and a network layer, and ARP and DHCP, which works as a network and a data link layer. So now we will cover firstly what exactly the data link layer does. So as we see that the data link layer, we use switches as the components. So then it is a switched network which able to communicate, which is helping two devices to communicate with each other by filtering out the MAC addresses. So now we see how these systems interact and how these routing is being done. So the communication between distant stations or end devices is typically done over a network of switching nodes. So we have to switch between one nodes to another. So switching nodes do not concern with the content of data. The purpose is to provide a switching facility that will communicate or transmit the data from one source to another via intermediate nodes. It is a collection of nodes and connections forms a communication network. In a switched communication network, data entering a network from a source station are routed to the destination by being switched from one node to another. So like you can see here, there are these personal computers, and then this is again personal computers and one server. So this is under the same network, but they want to interact with each other. So they basically connect with each other using a switching network, from where you have to switch from one node to another to communicate from one computer to another. As you can see, in intermediately they have multiple nodes through which you have to make a hop off. So switching nodes may connect to other nodes or to some other stations. Network is usually partially connected. However, some redundant connections are desirable for reliability. So there are two different types of switching technologies. So like we have to communicate from this personal computer B to personal computer F. So there might be a case in which it communicates from 1, 4, 5, and 6, or through 1, 4, 7, and 6. So there are multiple switched networks in which the computers can interact. So then we have to decide and figure it out how the two computers will interact. So for that, there are different switching technologies. One is known as circuit switching and another is known as packet switching. So in case of circuit switching, there is a dedicated communication path between the two stations. For example, initial stage only, the dedicated path is described like it has to communicate using 1, 4, 5, and 6. So all the packets and all the data will be sent through the same path. So for that, there are three phases. First is the established phase, that they establish the connection between the two computers. Then it is the transfer phase in which the data is transferred. And third is the disconnect phase in which the connection is disconnected. So no longer the data can be transferred from that system to another system. So for again building up, again transferring the data, they have to build up a new connection and follow these three phases all together again. So in this way, there is a possibility that if that network, if one of the node disrupts, then the message will no longer will be delivered to the final computer or to the destination, from source to the destination. So because of that, there is another switching technique that is called the packet switching, in which a station breaks long messages into packets, and the packets are sent out to the network sequentially, one at a time. So there are multiple packets. So for example, if there is a glitch in the network, then one packet will be lost, but not the complete packets of information. So there are, for example, as you observe in the daily routine, when you see send a message from your WhatsApp to a group, there might be a case that certain messages are being not able to send at a time because there is a loss of network connection. So, but that doesn't mean the other messages are also not sent. So the dependency is not there in case of the packet switching. So these stream of packets are routed through the network and are delivered to the intended destination. So there are two approaches for this. One is the datagram approach and another is the virtual circuit approach. So in packet switching, first we'll discuss the datagram approach, in which each packet is treated independently, and packets can take any practical route. That is, for example, if a packet is going from one source to destination, it can take any possible route. And it might be a case that the packets may arrive out of order. So for example, that each packet is treated independently. It starts from a route which is longer, so that might take a longer time, but another packet opts for a shorter route and reaches earlier, so the packets may arrive out of order. Packets are also having that cases of getting lost or delayed because of the because if something happens to a particular node in which they are following that switching nodes. So it is up to the receiver to reorder the packets and recover from the missing packets. And this approach is more flexible as routing can be used to avoid congested parts of the network. So there's this another packet switching technique that is called the virtual circuit, in which we define the pre-planned route established before the packets are sent. There is a call request and a call accept packets established, in which they establish the connection. So each packet contains a virtual circuit identifier instead of the destination address. So it has the another virtual circuit identifier which identifies the next node onto which it has to send the packet, not exactly the final destination address. So no routing decisions are required for each packet. There is a certain pre-planned routing for all the packets. So there is a no dedicated path, so it is less reliable as a loss of a node loses all the circuits throughout the node. So as you can see here, these packets are transferring independently. And if they are transferring independently, then it is the case of datagram. But if the packets have a predefined route, and if one of the node has a disruption or some issue, so all the packets will get lost. They'll not be able to reach towards the destination. So what is the major difference between virtual circuits and the datagram circuits is that in circuit, network can provide sequencing and error control, and packets are forwarded more quickly because no routing decisions are to be made in real time. And then this virtual circuit is less reliable because the loss of a node loses all the circuits throughout the node. And the datagram circuit switching helps no call setup phase. That is, it is better if there are few packets, and these packets and decides themselves to the path in which they have to transfer the data or to connect to a different machine. So the datagram approach is more flexible as routing can be used to avoid congested paths. As a packet can see that this path is congested and is taking longer time, so it can decides on the go if it wants to follow another path. So thank you. This was the overview of whatever you have covered in this complete week. And based on this overview, we will be discussing a few questions in the assignments. If you have any questions or queries right now, you can ask. Then we will move towards the assignment questions. Anyone having any queries can raise their hand. Yeah, I will share the PPT link, and the PPT link, if you need, that will be shared with you. Just a second. Wait. Akshit, you have any doubts?
Yeah, ma'am.
Okay,
Ma'am,
what query?
kindly explain the definition of switching nodes in simple words.
In simple words, what a switching node does is like there is a switching network in which there are multiple nodes which have to connect to each other. Okay. So in that, for example, you are sending a message. You want to send a message from one machine to another machine, but internally there are multiple nodes from where that message has to hop. So it is not a direct connection from one machine to another. It might be a case that it needs to be hopped through multiple different nodes. Like if I want to make a call from here to a different country, say USA, so for that the call cannot be made directly. So that needs to be communicated through various multiple channels. So there are multiple routes, and because there are multiple requests, so which route to follow and which node to send a request to, that is decided by a switching routing techniques. Is it okay?
Yeah, ma'am. Thank you.
Oh. So as far as I can see, you guys are talking about the WhatsApp group. I'm not sure like how can we make the WhatsApp group, because there are multiple guests and get gathering. Either any one of you just add up a link here for invitation regarding the WhatsApp link, and all of you can join there. And then later I can share the PPT link with you guys there if needed to be. So anyone takes the initiative and share a WhatsApp link, and then all of us can join there, and there I can share the PPT with you guys, and then I think we will also upload this PPT to the NPTEL team. They will be sharing that PPT link with you guys as well. So whichever way works. I'm not sure like are these PPTs shared with you or not, but we do share with them. So whichever way works, let me know. We have one more hour in which we'll discuss the assignments, upcoming assignments, and the week zero assignment, which has been given to you with the solutions.
Hello, ma'am.
Yes.
Ma'am, this is Devansh, and like you have said about switching, and
Mhm.
as you said, like it is also known as handshaking method. So, my question is like, does it obey some protocols or?
Yes, so packet switching obeys a handshake method only in case of virtual packet switching. Okay, in which they have a predefined route, and they have to follow that particular route, and they do a handshaking method as it is told here. Yeah. yes, either in the virtual network or in the circuit switching network. So for that case, the protocols are not exactly used, because this is done in the data link layer. But yes, data link layer also have certain protocols that I've mentioned, for which we will be discussing soon with you. Like it has the Ethernet, Wi-Fi, Bluetooth. So they have certain protocols in which what should be the range of the two nodes, and how the message should be communicated, what types of streams can be sent. So all such rules have been decided by these protocols, because this switching is done in case of data link layer only. And it also verifies whether the messages has been received correctly or not.
Okay, ma'am. Thank you, ma'am.
Yeah. So I see someone has shared a link with me in the chat. Let me. Okay. Then we'll continue with the assignments. Anyone is having any doubts further? I'll upload these PPTs in Google Slides or Google Docs and share the link with you guys. Okay. Okay, now let us move towards uh, these assignments. So firstly, we will discuss the week 1 assignment, as you can see here. Okay, so now I have taught you certain the basics concepts of this course. So I assume everyone would be able to answer a few questions. So let us see. I have considered this week 0 assignment. I think all of you have already been access to these assignments. So it would be great if you interact with this session and answer to me like whatever you think would be the answer to this question. So the question one is, which of this is not a network edge device?
PC, ma'am. B. Option B.
No, that is wrong.
Which
What are network edge device? Network edge device are the output devices on which the network is connected. So compute PC is a main network edge device. Edge is the output device. So we are not talking about the network devices, not the devices such as we discussed about the switch and the routers and the hubs, but we are talking about the edge devices on which the network is connected. Okay, so one of you answered switch. That is right. Switch is not a network edge device. The network edge device are the devices which are present on the edge. That is the PC, smartphones, and the server. Many of you are answering, so great. Okay. Server is again a network edge device. It is the device which are connected through a network. So that is a network edge device. That is the clients, the server. So clients may be the smartphones, maybe computers, maybe the servers. Okay. So as you see the explanation here, network edge devices refers to the host systems which can host applications like web browser, etc. A switch cannot operate as a host, but as a central device which can be used to manage network communication. So whatever communication is being done between the network devices is done using a switch in the data link here. So understood? So next question, what is the full form of OSI? Anyone?
It's Open System Interconnect.
Yes, open system.
Okay, great. So OSI is an abbreviation for Open System Interconnection. A OSI model, as we have discussed, it provides a structured plan on how applications communicate over a network, which also helps us to have a structured plan for troubleshooting. It is recognized by the ISO as the generalized model for computer network, and it can be modified to the design any kind of computer network. Okay. And tell me how many layers are there in ISO OSI reference model? This is so very easy question.
7 layers.
Great, many of you have replied it. There are 7 layers, as we have seen in this PPT as well. There are multiple. These are the 7 layers. Okay. Next question. What is the full form of HTTP?
Hypertext Transfer Protocol.
Great. So what type of network shares the communication channel among all the machines?
It's broadcast network.
Broadcast network.
Great. If anyone has any confusion or any queries, do let me know.
Ma'am, can you tell about multicast or anycast and anycast?
Yeah, unicast is from one system to another, and anycast means to any system on that particular network. Okay. And broadcast is to all the machines. But multicast is to a specific type of machine, the specific machine for which you mention the address. So for example, there are hundreds of machines, but you want to send a message to only 10 of them. So for that purpose, multicast is used. And anycast typically carries a unidirectional traffic, but broadcast is for many to many communication. That is, all the systems can interact with all the other systems. But in case of this anycast, you can only transfer the message from one to another, to all of them. For example, as you can see, there are some WhatsApp group in which the admin only can put up the messages. So that is the anycast. But the broadcast is the one in which all of them can interact with all of the other. Okay.
Thank you, ma'am.
So here is the explanation as well. The broadcast information is sent to all the stations in a network, whereas in multicast network, the data or transmission is sent to a group of stations. Okay, to a selected stations. Then comes in unicast network, information is sent only to one specific station. And then the broadcast address of the network is the last assigned address of that particular network. Okay. Next, identify the first network which was based on TCP/IP protocol.
ARPANET.
Apa-
Mm-hmm.
These, ma'am. Apranet.
Okay, 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 good. Then, what is the maximum number of hosts possible under Class B addresses?
Let's see, ma'am. I think 65,532.
Mm, let us all others also have the answers. Then
It's
we'll
effectively
discuss this
to
question.
power 16.
What?
2 to the power. It should be 2 to the power 16.
Okay, let us all others as well answer the question. This is, I mean, let me tell you, this is not right. This answer is not right. Anyone else?
Ma'am, I'm not aware of this topic, ma'am. Can you just explain me?
Yes, we will discuss this topic on the Jamboard. So you can see the Jamboard, right?
Yes, ma'am.
There are different classes. Mhm. Okay. One is class A, then it's class B, then it's class C for defining different network IDs and host IDs. So in class A, in all the classes, the designated bits are 16, that is 32 bits. Okay. So for class A, the wait, yeah. For class A, the first 8 bits are designated for the network ID. What is the network ID? And then the remaining 24 bits are used for the host ID. Okay. Then we see class B, in which there are equal distribution, that is 16 bits for the network ID and 16 bits for the host ID. Then there is class C, in which the distribution is 24 bits for the network ID and 8 bits decide the host ID. Okay. Okay. Now in this case, these are the bits which decide what will be the header provided for different classes of networks. So what will be the network ID and what will be the host ID. So in case of each of these networks, there are different possible combinations. So in class A, if we there are 2 to the power 8 minus 1 different combinations which are possible for different network IDs, because one this one bit has been designated for a particular for this one bit has been fixed in case of class A, that is it has been fixed with 1, and then these are the empty bits. Okay, so in class A only single bit has been fixed and the other bits are flexible to get the address for different network IDs. Then we have the host IDs, in which 2 to the power 24 possible combinations can be made for all the types of host IDs, minus the 2 which are designated for special purposes. That special purposes, one is the main network ID and one is for broadcast ID. If all the bits are 11111, then it will be a broadcast ID, and if all the bits are 0, then it will be a unicast only to itself only. Okay, so these are blocked for a special purpose. So these two IDs have been allocated for the special purpose in case of class B, class C, and class A also. Okay. So now, when someone asks how many different maximum number of hosts possible under class B address. So as you can see here, this is the network's total network ID is possible, and this is the total number of hosts possible. So in this case, total number of hosts possible is 2 to the power 16 minus 2. Those two are preserved for the special purposes. Okay. So you understood this concept?
Yes, ma'am.
In this explanation also in class B, IP addresses first 2 octets are used to represent the network number, which leaves the other 2 octets or 16 bits to represent the host portion of that address. So with the 16 bits, we have total of 2 to the power 16 combination, not 216. It's 2 to the power 16 combinations which are possible, which yields 65536 class B addresses. However, 2 of those numbers, the lowest and the highest values, are reserved for some special purposes, which I deliberately told you what are those special purposes. So therefore, the pool of class B addresses can support up to 65534 hosts. Okay. Anyone having any doubt to this question? Okay, so let us move to the next question. Suppose computers P and Q have IP addresses as mentioned here 10.20.5.25 and 10.20.5.9 respectively, and they both uses the same net mask n. Which of the values of n given below should not be used if P and Q should belong to the same network? So so let me tell you a concept here. What is a net mask and how we judge like whether that particular IP belongs to the same network as the other IP or not using that subnet mask. Okay. So in that case, what we do is if we do a bitwise AND operation between the designated IP and the net mask n, then that bitwise resultant AND operation resultant should be equivalent to the bitwise AND operation with another IP and that similar net mask n. So in this question, what you have to do is you have to check for each of the possible combination. So there are 4 different net masks given, and for each of that net mask, you have to write it in a bitwise representation and do the AND operation between the 2 given IPs. So I'll give a 5 minutes of time to all of you if you are able to solve this question. Otherwise, then I will share the solution as well. Yeah, Akshit, you have any queries?
I'm kindly repeat what value we have to add with what value.
Okay, so we have this. So we have the IP address, right? That is, can anyone speak out loud? What is the IP address given in the question?
I'm 10.20.5.
Hmm. Yes.
0.25.
Okay. Then IP1 is this. Then we have the net mask. Okay, net mask. Can you give the A option? That
Right
is
now.
255.255.240, I guess. Okay, for example, say. So another IP is also in the similar manner, 20.5.9, I guess. Okay. So now you have to see whether these two IP belong to the same net mask or not. So for each of the net mask, you have to do a bitwise AND operation with one of the IP, then with another of the IP. Okay. So now the representation is 255 is like all ones. Okay. Then again it is all ones, then all ones. And then this is 240, which is a representation which has a different representation. All right. So give what is 240? How is 240 represented? Can anyone tell me? Okay, this is 240. This is 0. So this is 240. And now you have to bitwise AND these values with the bitwise combination of this. But we can see these two are common and these things are also common. So the bitwise AND operation between these two will be the same. So the main difference is between 25 and 9. So now you have to check with 25 first. So the 25 is resembled as 1 1 0 0 1. So now when you see the bitwise AND operation between both of them, you will get a value 0 0 0 0 and 1, and then 1 1 1. Okay. So similar in this manner for 9 also you do a bitwise operation with this value 240 and see is the subnet is the resultant obtained is same or not. If the resultant obtained is same, then we can say the both the IPs belong to the same net mask. If the subnet if the resultant is different, then the IPs belong to a different net mask. Okay. So I'll give you a time and you solve these and then we'll discuss in detail the solution. So I've given you more of a solution only. So, but I will request everyone to just make a solution yourself as well. So that will be better for you guys also to practice. So anyone with that answer can let me know here.
Ma'am, for IP1, the network address will be 10.20.5.16, and for IP2, the network address will be 10.20.5.0.
No, no, no. You understood the question wrongly. I am asking whether which of the following net mask belong says that the two IPs doesn't belong to the same network for which
It will
values
be
of
in
n.
It will be A, ma'am, only it will be A. Rest all three subnet mask have wider range. So that means both of the IP address will belong to same network. If you apply the other three subnet masks, they have a wider range.
Yes. So did you you mentioned the theoretical reason, but did you practice it, or did you write it and did a bitwise operation between them?
No, I just use I just deducted 240 from 255. That is a bandwidth for on network 15. I mean 16 nodes will be.
Hmm.
So that's how I calculated this. Uh,
Yeah, that is good approach one, but there are few corner cases in which that is not covered as well. So it is always better you do that with the bitwise AND operation between the bits, because last 3 points are last three values are same, so the operation reflects the similar results, but the last two bits have a different values. So do a bitwise operation with the net mask given. So then you will be able to see then the resultant is also same for the other cases, but the resultant is different in case of 240. As you can see here, when we do it with a 9, the resultant here is different, as the value here will be, this is 1, 0, 0, 1 for 9, and then the resultant will be 1 here, 0 here, 0 here, 0 here, 0 here. Okay. So there are different resultants obtained. So we cannot rely on this same net mask. But when there is a similar resultant obtained, then the mask is valid. Okay, let us move to another question. Okay, so here you can see the explanation as well. So another question is, what is supernetting? So the supernetting, anyone with the answer? What is supernetting?
it's me, ma'am.
Combining small network to larger one.
Yes. So supernetting is a computer networking technique that combines multiple smaller network addresses to a single larger network addresses, and it is also known as root summarization or aggregation. So what is the opposite of supernetting? Can anyone tell me?
Uh, it's subnetting.
Yes. Good. So then we have this another question, that network layer guarantees the delivery of each packet in the same order in which it was sent. So whether this statement is true or false, as now we have seen the routing as well. So the network layer guarantees the delivery of each packet in the same order as of which it was sent. Is it true or false?
It's
No,
false,
ma'am.
ma'am. It's false.
As we send data from one PC to the other PC, we
Hmm.
would also cut down the data into smaller pieces. Then we keep into frames. Then where the packaging came into thing. From that point of view, from that theory, this statement is false. Like the order
Yes.
would
Ma'am,
be same.
that guarantee part is taken care of by TCP.
By the transport layer. So if you want a guaranteed delivery, that is the protocol is decided by the transport layer. So as we have seen, there are two protocols in the transport layer, TCP and UDP. So the TCP allows the reliable communication and the ordering of packets, but in UDP, there is no reliable communication. And also the TCP protocol in the transport layer is different from TCP IP protocol that we have discussed. Okay. So then let us move to another assignment. This is the assignment which has been given in the last semester, and this has been last year's assignment. So I will be discussing the questions from the last year because in the similar manner, this year's assignment has been prepared. Okay. So the first question will be, which of the following is true for bridges? One, it is also called a smart hub. And second, it filters the network traffic based on the MAC address.
Only one, option number A.
Okay, that is not true. I mean, one is true. That's fine. Then, but the second one is also true. I have also told in the slides as well, like the hub is able to transfer it broadcastly, like from one machine, if the request is coming, it is transferring that request to all the other machines. But that leads to a congestion in the network. So for that purpose, we are using a smart hub, which is known as bridge, which filters out the network traffic based on the MAC address. Okay. So both 1 and 2 are correct in this case. So when does email become reality? Does anyone has the answer to that question?
1977, I think.
Yeah, so in the course, they have taught deliberately the history of this computer networks. So in that, they have mentioned that the email becomes a reality in the year 1977. So bridges filter network traffic based on IP address. Okay. So is it true or false?
I guess true, man.
No, so you haven't understood the concepts. We discussed this in the previous question as well. So bridges filter out the network traffic based on the MAC address. And bridges, again, the question has been asked that bridges filters the network traffic based on IP address, but that is not true. So IP address filtering is being done by the network layer. So network layer follows router as its devices, not the bridges. So bridges and switches are being used in the data link layer, which filters out the traffic based on the MAC address.
Okay, ma'am.
Yeah. So this statement is false. So another question, which layer collects a stream of bits into a frame?
It's data link layer.
So where are the stream of bits transferred? In which layer?
At physical layer.
Yes, and then the stream of bits are collected into frame in the data link layer. And then what does the network layer does?
It decapsulate the packet. I mean, read the IP address of the frame.
Yes, it adds a header to the frame and then encapsulates into a packet, and that's the fragmentation. Now, question number 5, what is the socket address? Yes, many of you have answered. That is A, which is a combination of port and IP address. So socket address is the combination of port and IP address. The number of Number socket is an internal terminal for transferring and receiving data packets at a single node in a computer network. So which are the following are the examples of application layer protocol of OSI model. So I have told you these as well with the names, and you have been taught these in the lectures as well. So which of these are examples of the application layer?
FTP, ma'am, file transfer protocol, and domain name server, I guess.
Yes, that's correct. FTP and DNS. So FTP is completely done in the application layer, but DNS is a combination which is done both on application as well as the transport layer. Which of the following is or are true with respect to the transport layer? It is responsible for process-to-process communication. It provides a standardization for common type of packet exchanges.
So, ma'am, second is true for packet exchanges.
No, only
It's
one
one.
is. Yes, only one is true because it is a process. I told you that in transport layer, we need to connect from one process to another. So when you want to, for example, we want to send a message from WhatsApp from one mobile to another. So that WhatsApp connectivity, application connectivity or process to process connectivity is being done by the transport layer. And then the packet exchanges and all these things are done by the network layer. Oh, sorry. The application is responsible for standardization for common type of packet exchanges. That is, the standardization basically is done by that application, how that message or how that packet needs to be exchanged. But the end-to-end process communication is being done by the transport layer. Anyone query till now? Okay, then question number 8 is switch break up collision domain. Switches break up collision domain. Is it true or false?
Yes, ma'am.
Yeah, so that is true. So basically in switches, anyone having any doubt? Someone raised the hand. Akshit, do you have any doubt?
Yeah, ma'am.
Yes.
Ma'am, in the lecture material, I saw that collision domain is an Ethernet term. And what does this statement conveys?
Where did you see that statement? I mean, which lecture notes?
Provided by the course itself.
No, but that is okay. But I mean, what is the background where it is mentioned? I mean, I'm not able to understand that question. What did you ask again? Collision domain is an in Ethernet.
Yes, ma'am. Collision domain is an Ethernet term.
Yeah, so it mainly, I mean, Ethernet means in the physical layer. So the collision domain is an Ethernet term because it occurs in the physical layer. So here the packets collide because users are sharing the same bandwidth. As I told you that in case of hubs and repeaters, when the mainly in case of hubs, when the messages are sent, that is broadcast between the complete network. and so packets collide with each other. So those the concept of collision domain is an Ethernet term. So in that way they are meaning, I think so.
Ma'am, I just want to add on the question. Actually, there used to be a token ring, I mean, technology also, which was
Yes.
used here, and Ethernet was always a shared hub model. So that's what collision domain was only occurring in Ethernet. It was not
Hmm.
occurring in token ring topology or technology.
Yes, so there are multiple topologies, as you mentioned. One is the bus, then the ring, then token ring, and then Ethernet. And majorly, they have more identified them as well as there are some other as similar to them as well. So he mentions correctly that in Ethernet domain only, as we have mentioned, it is happening in the physical layer. So hub is used. So in hub there is a possibility of collision. So that is why they have mentioned it as a collision domain. So that concept is occurring in case of that Ethernet only. Okay, so next question. Uh, so we were talking, yes, switches breaks up the collision domain. That collision domain allows one device to send packet on a network segment, forcing other device on the same segment to pay attention to it. So if one other devices try to transmit during that period, it will lead to a collision. So switches only switches those frames from one port to another within the same networks. So breaks up the collision domain. Okay. Then what is the first search engine? Anyone?
Internet Explorer B.
No, Internet Explorer has just came up, but it was not earlier. So the
What I
option is
guess.
no, it is Arch. So the first search engine was Arch. So these history lectures have been given to you with the slides in the course outline, complete course outline. So which OSI layer is also known as medium access control layer or MAC layer?
Data link layer.
Yes, as you know that in data link layer, the packet filtering has been done based on the MAC address. So bridge is an alternatively called smart hub and is deployed to filter frames based on the MAC address. Okay.
Ma'am,
So
paper is in
the
which format? MCQ or subjective?
that I have no clue. That you need to ask to the course TAs. I am a live session PMRF TA, so we have no communication with the professors and their TAs. So those things you have to mail to the NPTEL team. They will mention you explicitly.
Okay.
Okay, so these are the two assignments that I have covered till date, and I've also covered few concepts. And now, if anyone has any questions apart from these, you can ask me. Okay, so we if somebody has created the WhatsApp group, I will upload the slides link with you soon. So if anyone, any other person also wants to join this group, you can just, I'm resharing that link on this chat again. So you can please join this work again. So what are you asking? What is the course outline? So are you able to access the NPTEL link where you have access towards to the network to that computer network course? Lakshay, I guess he has asked me the question. So wait, let me. Do you guys have the access to the course page? I hope so. Everyone does. Yes, so in that page only you can see the complete course outline as well. Anyone up with some query? Yeah, so let me show you this. Where is the course outline? As someone asked, now I'm able to access it. Yeah, so here you can see my screen. Here you can get the week 1 of the course, whatever lectures have been taught in the week 1. Then there is lectures with the week 2. So all of the details have been mentioned about the particular week as a course outline. Okay. And whatever announcements have been done are being done on this page itself. So you have to register for giving the exams, and you have to register for opting out the course as well. Okay, I think that is it. WhatsApp group, I just reshared now. Somebody please reshare it again. I'm sharing it. Just check if whether it is working or not. I have been seeing 21 members. Okay, then we end up this lecture here. Thank you for attending this lecture for the first week, and then we'll continue in the similar manner for the next week as well. Okay. Akshit, what doubt do you have?
I was asking when will be the next session.
So I will be taking this live sessions every Tuesday at the same time with the same meeting link. from 6 to 8 p.m. So on every Tuesday, we'll be having this session, and I'll be discussing about the overview of the week's outline, current week outline, and then we'll discuss the previous week's assignment and the current week assignment solution questions related to the current week assignment. So that will be helpful for you to solve the present assignment. Okay, so let us end this session. Thank you for attending it.